Finally finishing rational functions. Where's my thing live? Such a parade. So everybody gonna be here tomorrow? What the heck, Lisa? What the heck, Michaela? Where are you gonna be at?
I think all the juniors are going to be checked out tomorrow because they're supposed to go to the
Why?
no, tonight.
Okay.
Except tomorrow we get about 12:30. Yeah, they're getting out.
Well, aren't you just lucky? You guys are missing a fun day. Mrs. Burr wants help with the elementary to decorate the tree for Annabelle the altar out there. No, it's tomorrow. Because is it the new people coming tomorrow? So, yeah. Okay, so finally finishing this. Rational functions feels like it's taking forever. Hopefully remember how to find and graph rational functions, right? How they work. Horizontal asymptotes, vertical asymptotes. Now we have this last little piece, so we could have like holes in the graph. So basically there could be like an open circle on your graph. So it seems kind of weird, but basically this happens. So I'm going to say it occurs when the rational function is not in lowest terms. So basically, if you factor the numerator and factor the denominator, there's some piece that can like cancel out. So let's just say I have like x minus a times x minus b over x minus a times x minus c. Right, so this is a rational function not in lowest terms. Technically, if we were doing this algebraically, I could cancel this part out. So this is the same as x minus b over x minus c. So since they're identical to each other, their graphs will be identical to each other. There's just one little piece. So I'm going to say graphs are the same. So I guess if I was graphing this, I would just graph the x minus b over x minus c because it's reduced. There's less stuff with it. But the whole occurs at x equals a. So you'll still have to plug that into the x minus b over x minus c, the simplified rational function. But when you like draw a smooth curve with it, you'll have a circle there. So you'll stop there, then start again. And we'll go through it to explain more. But yeah, we haven't had any rational functions that were in lowest terms until this point. Okay. So we have two examples. We have f of x equals x squared minus 4 divided by x minus 2. So we're going to graph it just like we normally would, finding the asymptotes. First, we're going to factor the numerator and denominator and simplify. So in this case, what is the numerator factor to? Yeah, so it's a difference of squares. So it simplifies to be this. And technically, we can divide out x minus 2. So technically, this function is simplified to be x plus 2. So what does the graph of like f of x equals x plus 2 look like? A line. So basically, we're just graphing a line. We're going to have a hole at what point, though? Yeah, positive 2. So you take what we canceled up, x minus 2, set equals 0, and solve x equals 2. So I'm just going to start graphing it. Right. So if I was graphing, I would plot the binary stuff first, and then rise one, run one. Except when you get to x equals 2, that's where the hole occurs at, which is my next point, so then I have the circle right there. Which I could have found the y value for that hole by plugging it in. So y equals 2 plus 2, which is 4. So whole is at the quarter there, 2/4. Okay. Anybody confused on that? The holes? Oh, no. I mean, you can graph anything, so it's not only data. So, like all it all for 200 learning functions, I would say is modeling data. Statistics, making predictions, all that kind of stuff. Predicting where COVID's good luck with that. Okay, last one. So this was more complicated just because there's more stuff in it, but it still works the same way. So we should factor first, and then figure out what we have left to graph. So x squared minus 9 factors to be yeah, so it's a difference of squares, so it has to be positive 3, negative 3. Same with x squared minus 4, it's a difference of squares. So I have all these things that can cancel. So x plus 3 cancels, x plus 2 cancels, they're both on the top and bottom. I'm left with x minus 3 over x minus 2. So that's the graph that I'm actually going to be doing. So that's a lot more simplified. When I plug in points, it's a lot easier. But where are the holes at? So you'd set them equal to 0, x minus 3 equals 0. So technically. Oh, jeepers. Whoa. Back up the truck. Okay. Okay. Well, I want to start with this one, but so let's find the y value so I know what ordered pair has a hole. So x equals negative 3. That part I canceled out. I'm going to plug it into like the very end piece. So y is the negative 3 minus 3 over negative 3 minus 2. So then it's 6/5. So one hole occurs at negative 3 constant. So the other piece that I canceled out was x plus 2, which is x equals negative 2. And doing the same thing, I'm going to plug it into my simplified rational function to find the y value. So I know where the hole occurs at. When I said the hole is negative 2 5/4. Okay. So the holes is the new information, but this is still a rational function. We're going to graph it. So I need to figure out what is vertical asymptote and horizontal asymptote. Does anybody remember how we did that? So vertical asymptote is taking the denominator. You're doing horizontal asymptote. Yeah. So vertical asymptote, take the denominator, set equal to 0. So x equals 2 is 1 asymptote. Horizontal asymptote, we're looking at the degree, so the degree of the numerator is 1, denominator is 1, so the same. Yeah, so then I take the leading coefficients and divide them. The leading coefficients are 1 and 1, so just y equals 1. So I'm gonna start just graphing what we have. Okay,
You have to make code.
alright, so I have my asymptotes. I'm either gonna draw in my holes or circles or whatever. So -3 is at 1, 2, 3, 6, this. So like right above the asymptote. -2, 5, 4, same thing, like right above the asymptote here. And to finish the graph, we should just plot some points. So what x value is doing playing? Okay, so -0 and 1. We're gonna get the left side. -1, 0, and 1. Okay. -0. That's not good. Then we should do like 3 and 4 at least. Okay. -1. So we're slowly rising over here. 0 is 3/2. 1 is 2. Yeah. Slowly but surely, we are rising to the vertical asymptote. Okay. So that's 1/2 of it. Then when I plug in 3 and 4, I should get the other half. So if I plug in 3, 0, and 4, then I can plot points. And same thing, just we're approaching the asymptotes horizontally and the vertical one. So there's my graph with the 2 holes. Fantastic. Super fun. 4 problems.
I thought you guys did this on Saturday.
No,
So-
you're right.
Oh, you did it already?
Yeah, I think I did.
Oh,
No, I didn't do the holes, so. You have my sign there? Fix that.
Uh-huh.
What did you do on Friday?
Nothing.
Nothing? I thought you did this on.
You have a notice for Wednesday.
Yeah. Did I not post it?
Oh, I don't know.
Okay.